Okay, until now what we did, we start with a complex number. We saw the algebraic form of the complex number, right? We did z equals to x plus iy, and we did with z equals to x plus iy, and this is the algebraic form. We find out the solution by using this form. Now you have one more popular form, is called as trigonometry form or the polar form. Again, don't need to get worry about this, since you already aware of this concept. You already know the complex number. I assume that you know everything in algebraic form. If I give you an equation, now you must be able to solve it and find the solutions. It's easy, that simple. Now with complex, with trigonometry form, we will have another domain of seeing the equation. But again, we will do the same thing. It's nothing different, but in another way. Why we are studying this? Sometimes in the question, professor will ask you, find the solution of the complex number in both trigonometric form and algebraic form. Find the solution of the equation in both trigonometric form and algebraic form. So in that scenario, it's better to start with trigonometric form. You will see why. It's easy. You will get the trigonometry solution first, then you will just convert it to algebraic solution in just one line. So let's do it. As I said, the graphical, can you see this one?
Okay, yeah.
Sure. Or you can move it this side and he can like move here. So the trigonometry, as I said, the graphical representation, if a complex number is there, x plus iy, so I can imagine this is x and this distance is y, and this distance is known as the modulus of z, which is equals to x square plus y square root over, right? The distance from the center, from the origin to that complex number, is the modulus. So we can change it to a different form. It's the same thing, you're writing in a different form. So you mark this one as rho or p, whatever you say, and the inclination is the theta. So instead of writing x comma y, you will write p comma theta. What is p? P is the z modulus. P is the distance. Okay, and theta is the inclination. So what is theta? Theta is, okay, you know the basic concept of tangent. This is, if I consider theta, so tan theta is equals to perpendicular by base. So our perpendicular is x, no, perpendicular is y, and base is x. So theta equals to tan inverse y by x, right? You know this concept?
Yeah.
Like you have a triangle. If you magnify this image, you have a triangle like this. This is y, this is x, and this is z modulus. So you have a theta over here. So if you take the tangent of this triangle, tan theta will be perpendicular, this is y, by base, that is x, and if you take the theta, is tan inverse x by y, right?
Yeah.
So you can calculate rho, you can calculate, okay, from now on I will say this one rho. Okay, so if I'm saying rho, you consider this one. So you can calculate rho, that is the modulus of the complex number, and you can calculate the theta is just arc tangent of y over x. Arc tangent over complex, this y was the complex part and x was the real part. So let me just write it clearly. So rho, it can be calculated as x square plus y square root over, simple, and your theta can be calculated as tan inverse y over x. And what is y? Y is the imaginary part, so you can say imaginary part divided by real part. Okay, and yeah, so also you can write this coordinate as p cos theta and p sin theta. You know from physics, if you this rho has a theta, so you can write this one as rho cos theta and this one as rho sin theta.
Yeah. Right.
Okay, so you can write this coordinate as rho cos theta and rho sin theta. So z is rho cos theta plus I rho sin theta. I just substitute the value of x as this one and y as rho sin theta. You do understand why I took this one as rho cos theta and rho sin theta?
Yes.
So did you?
Yes.
So I just substituted here, then I got this rho cos theta plus I sin theta. And you know the properties of trigonometry, it repeats after every one circle, so you will get every same solution if you have the integer multiplication of 2 pi. 2 pi, why 2 pi? Here is pi, 2 pi, so you complete one circle, so every time you will have the repeat solution. So this cos theta is always equals to cos theta plus k2 pi, where k is an integer.
Why is this?
As I said, it's a trigonometry. If you complete
okay,
a unit
okay.
circle, you will always reach the same solutions. Got it?
Yes.
So now you got the idea how to switch from algebraic form to polar form. You just need two things: one theta, one modulus. That's it. And note one more thing: when you have the complex number in polar form, trigonometry form, so the basic the way we write the trigonometry form is rho cos theta plus I sin theta. So and you have another complex number which is r cos phi plus I sin phi. So if you want your z and w to be equal, condition number one, these two things must be equal. The rho and r must be equal, and this theta and this phi must be a the difference must lie in multiples of 2 pi. Why this one? Because theta is can be equals to phi also, but if for example theta is equals to rho plus something like maybe 5 times of 2 pi, like 5 times of 2 pi, so that means it's completing 5 circle and
Yes.
going to the same part. So these things are equal, so the difference between these two angles, these two angles must be in a difference of k to pi. If you consider k equal to 0, they both are same. If you consider k equal to 1, the difference between them is 2 pi.
Yeah.
So
One question.
mhm.
In the exam, we won't have the calculator. We're not allowed a calculator.
No.
So tan inverse whatever upon inverse.
Most of 99 point some percent you will get easy values,
Which
it's
we should
not,
remember.
it's not that complicated, but yeah, you will remember those things. If the calculator is allowed, you will get complicated values for sure, like in you will use in control system in electric circuit, you have the calculator is allowed, so don't expect
Easy
good
values.
values. But here you will obviously expect a good values mostly,
Yeah. Okay.
because without this you cannot proceed.
Yeah.
Yeah.
So we need to memorize the table in which all the values of tan inverse are given.
Yeah, maybe, or maybe you just like whenever you're solving question, just go to that and see the values. Practice makes you perfect.
Okay.
Rather than just remembering and not utilizing them. When you use them, you will remember it. Yeah. Until now, I said this thing. And if you have like rho, if you have something u theta and you have another one u phi, it will be u just theta plus phi. So both the complex number and a different. And Euler's equation, this one is a very popular one: e to the power I theta equal to cos theta plus I sin theta.
I don't understand this. What happened here?
I will show you with an example. So if you have like two complex number and the row are same, the theta is different. So if they're getting multiply, you just need to take one row and theta plus phi.
What is phi? Like theta is an angle. Phi is an
Angle of another complex number. I said here, so you have two different complex numbers
Okay.
and you want both of them are equal. So this is the main condition that I want to justify over here. And yeah, so your question, coming back to your question, so instead of this thing, instead of this very big thing like rho, you're writing cos theta plus I sine theta. I sine theta, I will just write rho, and this is as u theta. So if I have written u theta, that means is cos theta plus I sine theta. Okay. So here you have two complex number as rho u theta, and one is r u phi. And if you want to multiply this two, so this magnitude will be multiplied and their angles will be added. And if you want to take square of any complex number, is rho square u 2 theta. So theta will become 2 times and your rho will be squared. And if you take cube of this one, so it will be rho cube u 3 theta. You can check out the proofs, but as I said, it's just the basic things you need to know it before solving any exam question. So we don't go to the proofs. So I can conclude, if you have some scenario like this, k times, so it will be rho times of k u k theta. Okay.
Okay. Yeah.
Again, I just wanted to have some basic idea. So if you have a complex number I1 plus I, that is a plus ib, so here a equals to 1 and b is also equal to 1, right?
Right.
And you want to calculate the rho, is just z modulus, so it's 1 square plus 1 square, we got root over of 2. And we can calculate the theta. Theta is an arctang of the imaginary part upon the real part, so it's 1 over 1. Tan inverse of 1 is pi by 4. So that means I can write this complex number rho u the theta, rho u theta. Got it?
No.
This one is same as rho cos pi by 4 plus I sine pi by 4. Instead of those cos pi by 4 sine pi by 4, I will just write u pi by 4.
Okay. One thing, when we compute the inverse of the tangent to know the angle, we might have two different solutions for that. So here you choose pi by 4 because it's in the first quadrant. Or like 3 pi over 4 is also.
I got your point. But again, it will be the same thing. It will not make any change, I guess. If you even just add 2 pi, if you take theta plus k times of 2 pi, you will get the same thing.
As we, like in the lectures of the
Mm-hmm.
another tutor, we attended, he was very emphasized on that we have to choose only the valuable that is value
For
here.
example, let me think. It's a good question, but let me think about it, because when I solved question, I didn't mark that much.
What's his question?
His question is like, why I just considered pi by 4? Why not 2 pi plus pi by 4? Like, why not 3 pi by 4?
that's the first.
It's not pi by 4. It should be not 3 pi by 4. It's
Oh,
pi
okay.
by 4. But again, we are reaching the same.
Yeah, it should be
Tangent.
pi plus pi by 4.
Okay, when we add like pi 2 over
I got your
to
point.
every tangent, it's the same. I mean,
Yeah, if you added 2 pi's everywhere, you will get the same thing. So for example, if I'm in pi by 4 right now, as I'm here, right? So if you add 2 pi over here,
7 pi by 4.
no, not 2 pi, like pi 2.
Just pi. 2 pi upon 2 is pi.
Okay, yeah, that's correct.
You're talking about the first class that we had with that teacher, right?
Yes, right.
Yeah, he told us that, for example, for example, if there's like a plane and we get our angle over here,
okay,
okay, like 45, but our complex number is over here, like for example, minus x plus y, like whatever, a minus,
Mhm.
yeah, like minus real number plus y. So
Mhm.
he told us that since there will always be this angle and this angle will be equal, you can
Mhm.
always just plus 180
Mhm.
and get your angle for the quadrant that
Here.
you want. Yeah, because this is the wrong quadrant and this is the correct quadrant.
But for me, I take every angle from here. I don't.
Oh yeah, sorry. Yeah, from here.
Okay. But also, I don't take angle from here. I take this angle as like this.
Oh no, but that he didn't show us.
Because if you see this, if you,
No,
I
he never
go,
mentioned this.
I go this one. For me, I don't make those things complicated. I go 90. Okay. This one is 180, and this one is 270.
270.
If something is here, it should be in between 270 or 360. If you are writing minus 45,
Yeah.
so it's the same thing if I justify with 270 plus
It was
45.
exactly that value, minus 45, but he told to choose like 135 to be in the second quadrant.
I got it. I got it. If okay, I got the exact question of you. I will check it out myself. First of all, then I will say. I don't want to
Yeah, he
confuse
can
you.
send us the notes, but
I will ask him his notes and I will go through his thing. Yeah, you
Okay.
whatever you are saying, there is a concept. I know about that. But I will check first myself. Then I will tell.
Okay.
When did I write all this?
Okay, now important first.
Yeah, if we get stuck anywhere, I will just but anyway, I will go back and check your point that you said, and I will also talk to him about this one.
You see, you take this angle. Since this and this is equal.
Just a minute. So I apologize for the mistake. Now I can tell you the exact correct person. So yeah, it is correct. If you have the complex number, you have to check the quadrants as well. If you have like something 1 plus I, so it's x is positive here. The like real part x is equals to 1 and y is also equals to 1. So both of them are positive, so they lie in the first quadrant. Okay, so direct the formula will be tan inverse y upon x, and you can cross check it out. If you get the value between 0 to 90, you are pretty sure that okay, your angle, you are in first quadrant. If your x is negative, for example, if you have this one, so let me just do it like this. Here you have 1 plus I, here you have minus 1 plus I, here you have minus 1 minus I, and here you have uh, 1 plus 1 minus I, right? So this one is 45 degree, and this one, if you consider, you have to go here to here, so it's 45 plus pi, that is 135 degree. And if you consider here, so it's this one is
No, it would be 45 minus pi.
no, if you see this side, I'm talking about going this side.
Oh, okay.
So if you consider this one, you just add pi to 135, so it's 135 plus pi. And if you see this one, this one, so it's 1 is 45 plus 2 pi, no, it's okay, you are adding pi by 2, pi by 2, pi by 2, so pi plus pi by 2, pi plus pi by 2. Yeah.
Wait,
Theory by right?
what's the difference between this and then this outer one?
Sorry, the outer one is going here.
Yes, thank
Yeah.
you.
Okay, so in conclusion, what I said, if you have a complex number, you can check the sign of those x and y, and according to that you will decide which quadrant they belongs to, and depending on the quadrant you can apply these formulas for calculating the values. But even you don't remember these formulas as well, is completely fine. Whatever you can do, for example, if you imagine, if you got this one -1 plus I, right, and you got your angle like 45 degree. So you can see this lies in second quadrant. 45 degree cannot be possible, so you can think about some angle in between 90 and 180. So you just plus pi, you reach there 135. Yeah, so that's the trick, and you can always cross check whether you are doing correct or not by checking this thing. If your quadrant is fourth quadrant, the angle must be in 270 and 360.
Okay, for the tangent inverse, we always have two values.
For not two values, it can be many values.
No, in like 2 pi. Like I know we have many values, but in one complete circle.
Yeah, in one complete circle, yes. So
okay, so we check which of them.
Yeah, you check which of them according to the quadrants.
Okay.
List of the quadrants. Yeah. I didn't consider this point before.
It's good that his memory is good.
Yeah.
Nice memory.
Awesome.
It's a little bit cold. Can we turn off?
Okay, so we did an example of this one. Then we had the other one. For example, if you have I plus 1 plus I to the power 100, so is this one to the power 100. So as I said, you just take the power of rho to the power 100 and you multiply 100 over here. So that's the thing you need to do, is root 2 to the power 100 u 100 pi by 4.
Yeah.
And this 2 to the power 50, and if you see is 25. And as I said, you get 25 pi, which means the same. If you take like round until 24 pi, you will this reach here and you will just go one more pi. So it's same as writing pi, because the value will be the same.
First, we will not divide this by 2.
Divide
because
this.
each circle is 2 pi.
Yeah, so as I have said, no, if you see the nearest number that is near to 25 is 24 pi. So 24 pi, that means they take 12 circles, right, and then they reach go pi. So instead of writing 25 pi, you can just write pi. It's the same thing.
Okay.
And some notes, you can just, if your z is just 1, that means is 1 plus 0 I. So it's like 1 plus u 0. They're writing the same way. And if your z is -1, so it's -1 plus 0, so it's 1 u pi. And if you have z equals to I, so it's 0 plus 1 I is 1 plus u pi by 2. You can prove it using, sorry?
I didn't understand.
Yeah, it's just like the normal complex number. If you have a complex number as z equals to -1, that means -1 plus 0 I. And when you convert to the polar form, you will get 1 u pi. You can take the tan inverse. This lies in which quadrant? So it's -1, right? This is -1 0. This lies in here. It's exactly on here. So you can check the angle is 0 to pi. So the angle is pi.
Okay.
Again, this one lies in 0 1 I. So it's like here. So its angle is pi by 2. So that's the common complex number that you will use in the future questions. It's just for your reference. And one more important theorem for this question is De Moivre's theorem. So every complex number which is not equal to 0 has precisely n different roots, and see. But the most important part is like, if you have a complex number, sorry, if your complex number can be written as wi to the power n, so your z is
Okay, sorry.
it's okay, no, you can do it.
No, it's fine.
So your z is rho u theta, and your rho is greater than 0. If you want to write it in w, so you, if you can easily see, is this one as this is wi root over of z power n, right? So if you want to write this, it will be in this form. So this root over of the rho u theta divided by n plus pi k 2 pi over n, and your k must lie between 0 to n minus 1. That's the de Morvis theorem. So in short, if you have something like this, wn is a complex number, and sorry, wi is roots of the complex number, and if you want to write, the roots will be root over of this one. And so de Morvin's law state that if your z is equals to rho u theta, this will be root over of rho over n. Your theta must be divided by this power n, and you know it repeats itself after k 2 pi, so it's open n. You will see one question, maybe in that your concept might be clear. So for example, let's solve this one, so it can cover all the previous concept that we want. I want to solve it actually, so that it's much more clear. Okay, so question number 1, you have 8 upon z3 is equals to 1 plus I over 1 minus I, and your z belongs to the complex number. And the question asks, solve and write the solution in algebraic form as well as in trigonometric form. Okay, so let's convert it to, no, let's first bring it to a form. So is, I can write it as z3 upon 8 divided by 1 minus I upon 1 plus I just reciprocal it. Then I can write z3 is equals to 8 1 minus I 1 plus I. So if I can convert it to trigonometry form, this one you see is you have to calculate the row of both of this is the same. So row is 1 square plus 1 square, that is root over of 2.
Is the module?
Yeah, modulus. So I can write this one as row as root 2, but some here this one is, you know, is tan inverse 1 upon 1, this one, so it's 45 degree, and this the upper one
minus 45.
yeah, it's minus 45. uh, yeah, so 8 root, this one I can write root 2 row minus pi by 4, and this one as root 2 row pi by 4,
Row as in,
and this 8 I can write as 8 u 0, correct or no?
this is not the trigonometric form yet, right?
It's the trigonometry form.
Rho.
I have written rho, that means is root 2 cos pi by 4 plus sine pi by 4, and I is there.
Yeah, but can we do that in the paper? Writing just a rho.
Yeah.
We can?
Yeah.
Okay.
So as I said, there was some theorems. Okay, I can cancel this one, right? And this is 8u0, and this one will be u negative pi by 4 plus pi by 4, right?
Yeah.
No, negative pi by 4 minus, this is in denominator, so it will go to numerator, so it will be negative. So as I said here, just a minute. Yeah, if you multiply both of things, you can add the uh, angles, but if it is u upon theta upon u upon phi, so it's u theta minus phi. I just used this one over there. Didn't came. Okay, so here I just use this one rho theta upon rho phi, that is equals to u rho theta minus phi. Clear? After this I got 8u0 plus u, this one will be minus pi by 2, and since this thing is multiplied, you can write 8 u minus pi by 2. You can add both of them. 0 plus minus pi by 2 is this much.
But what happened to the 0?
As I said, if something is getting divided, you can subtract. If something is getting multiplied,
Okay.
you can just add them. U theta into u phi, so it will be u theta plus phi. I did that. U theta plus phi.
And the only thing that I didn't understand was first we get the modulus of here and here, and what is it after this step?
Then you need the theta. So the theta is this for this one. You can write
The module of this, the module of it divided by each other or no? There.
Okay, first of all, you have to convert this one and this one and this one in the trigonometry form. Okay, to convert to a trigonometry form, a complex complex number, you can write this. Just see here, I'm writing it over here. So I want to convert this one to the trigonometry form. So I need rho and the angle. Rho is 1 square plus 1 square, and the angle is, since this is in the first quadrant, so is 1 upon 1, that is 45 degree. So this is root 2, so I can write this one as root 2 rho pi by 4, right? Same. And we had one more complex number as 1 minus I, so you can write 1 minus I as, you see the row will be the same because it's 1 square plus 1 square, you got root 2. Okay, and the angle theta will be tan in, but you have to check whether it is in first quadrant or second quadrant. You can imagine this one as 1 minus I, so it's
It's here.
yeah, so it's over here. So you know the value must be between 270 and 360. So this one will be 1 upon minus 1, so it's negative 45 degree. So if you take the angle from here, it's negative 45 degree.
Okay.
It's the same thing if you take it from here as well. So I got this one and this one. Then I substituted all this thing over here. So
Okay.
8 can be written as u 0, 8u0. Then I this modulus
Gone.
got cancelled, and this theta's got added. Sorry, subtracted, since it's in divide form. So this is minus pi by 4 and this is pi by 4, so you can just take to opposite side, and this minus pi by 4 minus pi by 4, I got minus pi by 2. Right now I reached here. But if you see here, now our question is z3 8 u minus pi by 2. Now we need z. What to do it here? That's the question. Now we can apply our De Morvis theorem. So if you apply De Morvis theorem, your z will be
So
8 root 3. Okay.
one question.
Yeah.
8 u minus pi by 2 is equal to 8 in times cos minus 90 plus I sin minus 90.
Yeah.
Are these two equal?
Yeah.
Okay.
This one is same as 8 cos.
Are we sure that we can do this in the exam?
Yeah. We do it always.
In the exam, right?
Like just write u instead of cos and I sin.
Yeah, but I don't know if this is defined by everyone yet.
Yeah, it's defined by everyone. Is defined in the notes.
Okay.
Yeah. Whatever you're seeing here, you can write it in the exam. Don't worry. So the same thing. Now you look at here. You have z3 equals to this one, but you need z since you are finding the roots. Here you just need to take the root over of cube root of this one u, and the first step you need to do is minus pi by 2 divided by this 3 plus k 2 pi divided by 3.
Wait a
That's
minute.
by D Morvis theorem.
Shouldn't we only just multiply by 1/3?
What?
Where is this come from?
As I said, you will get the same repetition of the roots. You will not just get one solution, you will get multiple solutions. So you have to consider all of them. And one more important thing, the value of k is 0 to n minus 1. So your n is 3, this is your n. So this 0, 1, 2. This is by De Morvis theorem. If you want to find the solution, something has some power of something, like if you have like z to the power 4, you will take instead of 3, this will be 4, and it will be divided by 4, and this will be divided by 4.
So we have, this is the, what's the equation, what's the formula of De Morvis theorem?
You can note it from here. So
Okay.
you will get the notes. So
Okay.
right,
What was this then?
it's in exponential form.
Oh, polar form.
Yeah. Polar form is this one. This is an exponential form. We are using polar form same as a trigonometric form. The same thing.
The exponential is what? Polar form is the
Yeah.
trigonometric?
Yeah, exponential is like, we have the Euler's equation is equals to cos theta plus I sin theta. So it is behaving as your u, right? Because u is this one, and you just need to multiply the row. So rho is z modulus, and so you can write z modulus e to the power I theta. This is the exponential form.
Okay.
Same thing that we're doing here. It's not much difference. But am I clear in this theorem?
Yes.
Because this is much important. Did you understand completely how I moved from here to here?
Yes.
Yes, I did.
And
Okay.
the value of k is 0 to n minus 1.
How did the value come?
As from De Morvis theorem. It's the
Oh,
value
after
of-
you solve it?
Yeah.
Okay.
The value must be lie from 0 to n minus 1. Here you see the magic by this theorem. Now the question got extremely easy from here. So my solution will be z 8 root 3 u minus pi by 2 upon 3 plus, if you take k value 0, k value can be 0, so this is 0. Other solution is root 8 u pi by 2 upon 3 plus 2 pi by 3 is the second solution. And the third solution is 8 root 3 u 2 pi by 2 upon 3 plus, if you take k value 2, is 4 pi by 3. So if you simplify them, you got z equals to root over of 8 is 2, right? U, this one is negative pi by 6 comma 2 u, and if you simplify them is pi by 6 minus pi by 6 plus 2 pi by 3. So if you simplify it as
Minus 2.
let me just copy it from here. So if you simplify them, you will reach minus pi by 2, right? This one is, yeah, minus pi by 2, no sorry, positive pi by 2, and the other one, this one will be 2u 7 pi by 6. Got it?
Yes.
So this is the solution in trigonometric form. But as the question asks, you also need to have the
Algebraic form.
algebraic form. So for the algebraic form, you have to write it in this way. So your z is 2 times, if I do it for this one is 2u minus pi by 6, right? So it can be 2 cos minus pi by 6.
For the algebraic, we just bring it to the sinus and polar form.
Yeah, algebraic form you have to you can convert it easily from here to there. It's okay. Sine minus pi by 6. So if you put the values of this one is 2, 3 root 3 over 2 minus, this is 1 upon 2. So if you multiply everything, you get root 3 minus I, root 3 minus I.
And this was this a new question?
Sorry?
Wait, what was this?
The question was find the solution in algebraic form, in trigonometric form. First,
Okay.
we did what? We converted everything to trigonometric form. We solved it. We got the trigonometric solution first.
Okay, which
Why?
was 0, 1, 2. Okay.
Yeah. Why we did the trigonometric form directly from the beginning? Because we saw something cube and something. With algebraic, it would have been extremely difficult because we have the De Moivre's theorem. It's directly applicable on the trigonometric form. So because we converted into polar to the trigonometric form of the polar form, we can apply the De Moivre's theorem directly, and since we applied the De Moivre's theorem directly, we just got this one. Or else in algebraic form, it would have been super difficult to find like 3 roots.
Yeah, of course.
Did you got my point? Is it any?
Yeah.
Do you have any question? If you have any questions in this part, you can ask me right now. Yeah.
The last line of the. Oh, okay. Here, when you transform the algebraic form, the trigonometric form into algebraic, then this u disappears. Can you define u once more? Just know how to.
U theta is just cos theta plus I sin theta.
Okay.
Instead of this thing, I'm just writing u theta. So to convert algebraic form, you need the value of theta, you need the value of sin theta and cos theta. So when I had like 2u pi by 2, that means is 2 cos pi by 2 plus I sin pi by 2. Then if you what's the value of cos pi by 2 is 1 plus no 0 0 plus I1, so it's 2 times of 0 plus 2 1 I, so it's 2I. Got it?
Okay, yeah.
Sure.
Yes.
Now you can
Uh,
convert from trigonometric form back to algebraic form, right? Easily.
Yes, but I have to know the sine and cosine of the angle.
Yeah.
Yeah, that's what I said as well. At the very beginning, I really have to memorize them. God damn it. Okay, so in the beginning, 8u.
But the most important part is the De Morvis theorem.
Yeah.
Okay. Yeah.
Because of only of this thing, we find out 2-3 solutions so easily. And this is the past exam question. There will be one more question. Yeah, we
I
can do
didn't
this one.
understand the first two lines. Could
First,
we go through the first one?
first 2 lines, like where?
Yeah, like over here. What happened?
Okay. Did you understood here until this line?
Yeah.
Then did you understood this one?
Yeah, that's
Sure.
more. Yeah.
You change the value of k.
Okay.
Take k equal to 0, you get this one. Take k equals to 1, you get
Okay.
the second one. K equals to 2, you got the third one.
So that's how we converted into algebraic form.
No. You are in trigonometry form. This is a solution in the trigonometry form. You had a.
Oh, so this wasn't the solution. 0 1.
No. This.
Damn.
You are reaching the solution. You
Okay.
just applied the De Morvis theorem. And then you convert to. Then you got the solution in trigonometry form. Then you convert it back to algebraic form.
So first we put 0.
Yeah, first you put 0, then you put 1, then you put 2.
After putting 0, we got this.
Yeah,
Then we put 1, we got this.
yeah,
Then we put 3, we got that.
yeah.
And then what did we do? We just.
You just simplify these things much better.
Oh, okay, then these are the solutions.
Yeah, these are the trigonometry solution. Then you convert each of them to algebraic solution like this.
Okay.
Okay?
Then shouldn't they be like 3?
Yeah, there will be 3. I just did for 1, so you just do for 2. Here in this PDF you have for the 3.
Okay.
Okay, now many people ask like why I did it in trigonometry form. Why not in normal algebraic form? You go do it, it's too long. Because of De Morvis theorem, we are safe. Now you will see some question like this one we will solve. This is also one past exam question. 9I Z 5 16 Z conjugate.
Okay. We can solve this by writing z as
So
a plus ib.
you can solve it writing j plus a plus ib. So you have to solve a equation which is in the order of 5. So if you put x plus iy, it will order of 5. If you can solve it, you are welcome to solve.
No.
So that's the thing, you cannot solve it. So always you will think about the trigonometry form.
Okay.
And one more thing, z equals to x plus iy. Okay, z conjugate was x minus iy. So z can be written as rho u theta. So z conjugate is rho u minus theta. Okay.
Why is rho?
You can prove it out.
Rho was a conjugate, right?
No, it was modulus.
Yeah,
Rho was modulus.
Modulus, yes.
Yeah.
Modulus. Okay.
Rho is a
Modulus.
x square plus y square root over. I'm saying when you do the conjugate, when you do the complex conjugate in algebraic form, you just do the negative of the imaginary part. But when you do the complex conjugate of complex form, you just take the negative of the angle. Okay.
Oh, okay.
So clear?
Sorry, what did you say?
Okay, when we take the complex conjugate in algebraic form, we will just take the negative part of the imaginary. But when we do the complex conjugate of an trigonometry like polar form, you just take the negative angle. Don't touch
Okay.
the modular. You can
Okay,
prove
okay.
it by taking some example, but yeah, you can do it by your own. But this is the thing. Okay, clear?
Okay, yeah.
Now we just left with this question is 9I. You can write this one as rho u theta whole to the power 5. This will be 16 rho u minus theta. Yeah. So first you can apply the one that I have said you. This one will be rho to the power 5 u 5 theta, right?
Yeah, right.
This equals to 16 rho u minus theta. Then you want to equal to complex numbers, so you want to yeah, so this is a complex number and this is a complex number. I am saying this is z, this is w. So if you want your z and w to be equal, g and w to be equal, the first thing must be your rho of z must equals to rho of w, and the theta of z minus the theta of w should be in k times of 2 pi.
Okay. Don't understand the second.
Second one, okay. If you go back to the very first, yeah, as I have said here, if you have two complex numbers z and w,
Okay.
z and w to be equal, this rho and r must be equal, and the angles must be, and the difference between those angles must be in multiples of 2 pi, integral multiples of 2 pi,
Okay.
because the same thing again after the circle you will get the same values. So the difference between the angle must be in the multiple of k 2 pi, and if you take k equal to 0, they are same. If you take k equal to 1, the difference between the angle is 2 pi. That means if you one is here and the other one is just coming moving around whole circle and coming back to the same angle, so it's the same angle.
Yes, now I understand.
Yeah, so it's done now. We got, if you equate this thing, we according to our question, so this one is yeah, so it's I over here actually. Just a minute. Okay. I made I forgot to do something over here. There was a I over here, so you can write this one is 9I. Say, so it's like u pi by 2. As I said, whenever you see just I, is u pi by 2. So this one is rho 5 u cos u 5 theta. This one you can write u 16 u 0, and this is rho u negative theta. I just converted this 16 normal 16 in trigonometry form and 9I in trigonometry form. So 9I, if you convert this, 9I is equals to 0 plus I9, right?
Yes.
So if you take the modulus, it's just, if you take the modulus of this one, the rho will be 0 square plus, yeah, 3.
No, let's get 9. Zero
Yeah, yeah.
2, 9 to the power of 2, naturally.
You confused me.
This is the last question.
0 square, this is 9 square root over, so you got the rho as 9, right?
Right.
So then the angle, the theta will be tan inverse, just a minute.
Tan inverse of 9 divided by 0, which is like pi.
Yeah.
Pi by 4?
No,
Pi.
pi over 2. imaginary part by real part. So it's pi over 2.
9 divided by 0?
Is infinity. Tan inverse infinity is pi by 2.
Yeah. Okay,
Clear?
if you have the trigonometric circle there is in the pi 2, the sine is 1, the cosine is 0, so the tangent is
Tangent is
not defined.
tan theta is sine theta upon cos theta. So if you take tan pi by 2 is equals to sine pi by 2, that is 1 upon 0. So it's not defined as infinity. So if you get like 9 by 0, it's not defined. So tan inverse of not defined is pi by 2.
Okay.
Yeah, but I converted everything now to the normal, to the polar form. So here if you compare all of this, if I can write this one as 9, since there are two things are multiplied, so it will be added, the theta will be added, right? So this is 9 rho 5 u 5 theta plus pi by 2. Okay, the two thing
Yes,
is
yes.
multiplied, so
Okay.
and this one is 16 rho u minus theta, right? 0 plus minus theta is minus theta, correct?
Yes.
We'll multiply these together.
Yeah,
Okay.
and those u will be added, the angle will be
This
added.
will be
How
added.
does minus theta come from?
Minus theta is given in the question. No, it was given, no, z conjugate.
Okay.
So as I said, z is rho u
Okay.
theta, and
Okay.
am I clear until now?
Yes.
Any question until now? What I did?
No.
Sure.
Yes.
Now, if you go back to our original idea, if a complex number to be equal, the row, this is the whole row and this is the whole row of this one. So this must be equal. 9 rho to the power 5 must be equal to 16 rho, and the angle 5 theta plus pi by 2 minus theta. Okay, minus theta plus. You don't understand? This one is minus theta will be k times of 2 pi.
Yes.
Okay.
Nice. Then you can just get the solution from here directly. So if you see, whenever you cancel one thing like this, don't forget to take rho equal to 0.
Yes.
No, but
That's,
how do we cancel this? Because p to the power 5.
Now,
Oh, okay, thank you.
yeah.
Why rho equal to 0?
Yeah, because if you're cancelling this one, you are missing one solution. So that's rho equal to 0. If you don't cancel, if you take this one here, if you take this one 9 rho 5, this one will be 16 rho equal to 0. So if you take a row common over here, so it's 9 rho to the power 4 minus 16. This equal to 0 and this equal to 0. So you are forgetting the
okay.
solution. So whenever you cancel, just remember you are doing this one.
Okay.
Got it?
Yes.
Sure.
Yes.
Nice
Yeah.
reminder.
Mostly, or like you will miss a solution if you do this thing, if you forget to do that. Then here is 9 rho 4 equal to 16, and here you can just keep the theta over here is 6 theta, rest you can take that side. So minus pi by 2 plus k 2 pi, right?
Okay. Yes.
And here I can say so rho equal to 0, but I'm doing for this one. Rho to the power 4 equals to 16 upon 9. So rho equals to root over of 16 over 9, but this one, sorry,
4.
clear?
Okay.
Yes.
This one will be 2 root 3. Rho is 2 root 3.
Yes, correct.
4 is like 2 root 2.
Is minus 2 over root 3 is also the answer, right?
Sorry?
Minus 2 over root 3 is also an answer.
Your modulus cannot be negative
Okay, yeah.
because it's a distance.
Okay.
So, right.
Yes.
And here you can write theta is equals to minus pi by,
Here is a 4, root 4.
yeah, root 4, but if you remove this one, it's root 3.
Okay.
You just take one time, no? It is 6, 9 can be written as root 3, root 3, root 3, root 3. 16 can be written as 2, 2, 2, 2, 2. If you take 4, so you just take one of this. Clear? 6 theta equal to this, theta equals to 6 will be divided.
Okay.
And the value of k will, just a minute. The value of k must be less than this 6. So it's 0, 1, 2, 3, 4, 5. So now you have this one 2 over root 3 u minus pi by 12 plus k 2 pi upon 6, and the value of k must be 0, 1, 2, 3, 4, 5, because we were finding the root, the maximum power of this one was 5 and the theta was like 6 theta, so that's why our n is 6 over here. This one is n theta, right? N theta. So if we're dividing the n, so this is the value of n is 6 here, so the value of k must lie between 0 to n minus 1. And now if you substitute the value of k over here, you will get for k equal to 0, for k equals to 1, for k equals to 2, k equals to 3, k equals to 4, k equals to 5. You will get different solutions. Then you will convert them to algebraic form if it asks in the question. If it doesn't ask,
We bring it to the polar form or the algebraic.
no, you will get the solution in the polar form. Then you, if it's a question is given, convert this to algebraic form, you have to do it. Am I clear?
It's one thing about the values of k. Here, like the Morvis you are applying.
Yeah, so if you have n theta, okay, and so if I want to calculate for theta, this one will be divided upon n, so the k value of k must be between 0 to n minus 1.
Can you show that the Morvis?
Yeah.
Okay. Like you're getting root fourths of, so why n is here 6 and then don't understand.
He means that n is 6, so why it
Why?
is not a square root of 6?
Yes.
It is 4.
Yeah, but we didn't apply the De Morvis theorem directly, we just compared it. This one, it says that if you have a complex number in this form and you want to directly get the um, if you want to directly get the solution, you can use this one directly, but we didn't use the De Morvis theorem directly over here. We just like compare both of them. We just showed that okay, for what value, what are the solution if when both
Okay,
of them
you
are
use
equal.
this one as the Morvis. This one is another rule.
Yeah, this is like the we as I defined in the beginning. of today's session. We were equating the magnitude, and the difference between the angle is must be in this thing. And here, if whatever is the multiple of theta over here, this is the n.
Okay, here this is the.
Yeah, we are not applying exactly De Morgan's theorem over here because we are just equating it and solving it. The last question was the direct application of the De Morgan's theorem. The last question that we solved, this one was the direct application of De Morgan's theorem because it was exactly in that form. Because this one, we are just finding the solution of this equation.
Okay, now I get it. Here we cannot apply it directly since we have like now
Yeah.
I here.
If you, I think you can also do it if you have, if you write it in this form, maybe 16z. Now you can directly apply. That's your task. You can try this one.
Okay, I will like try it.
You will try this one.
Seems this one yours is.
Yeah. No, I think this will also. You will get a correct answer with this one.
Okay.
Try with this one. So take z and other thing to that side. For sure, it will be correct answer. For sure.
But the power 5.
But you have the De Morgan's theorem.
Okay.
First, convert everything to polar forms.
Yes.
Power 5 is like 0 to 5.
Yeah.
Yes.
So you will get exactly the same solution. So your task is to do this one and find out and solve this one, this exercise. For sure, okay, I have some task to do for him. In the afternoon, you will receive the timetables of your classes.
Okay.
By evening at most. By evening.
Afternoon
Fine.
is evening
no,
is
that's,
night.
That's fine. Yeah.
Sorry?
It's fine.
No.
Since I have like 4 classes, I need to have.
Okay. Now we finished one complete part of your exam. That is complex number is done. So if you get one question from complex number, and if you have go through my notes, and if you have understood what I said, even you can when you're solving any problems, if you got any doubt, you can ask me as well for sure. But if you understood everything, for sure that you're gonna solve that question. I covered most of the important and trickier exam questions that it was asked in calculus 1, and I see the complete syllabus is the same. So if you practice this one, your one question is completely done.
You send us like some exercises in complex numbers.
Yeah. I will send complex number, and I have to send basic vector spaces and linear maps. Did you watch the video 1 and 2
Yes,
completely?
yes.
Okay. So I have covered the vector space in video number 1, and I have covered some 2 questions from partial 1 in that video. And I will also suggest you to solve after this one, try to solve the partial of your exam. It was uploaded in the Moodle. Don't check the solution. Okay. Don't check the solution, just try to solve it. Even you don't solve it, it's okay. I can give you the hints how to solve it. Like, don't see the solution. When you see like a single question can be solved by 5 different methods, but if you just see the solution and you check it, like you are just training yourself with other methods, and at the end of the exam you get confused. So since I said you linear algebra is easy but confusing, so you just follow one method that which I am saying to you, or else if you are pretty sure about your techniques, you do that. But since I'm guiding you, so I just say you the most easiest method possible, you just go by that way.
Okay, you mean after finishing this lecture, I'm able to solve the first partial?
Yeah, 90% or 80% of the question if you understood my lecture 1, lecture 2 and this one. Not the
Okay.
complex number one, but this both of them. Yeah. So I have picked two questions. First one I will solve it, and the second one is for you. But both of them are solved. So consider a linear map that goes from T R3 to R3, and it's given as D x y z. You have the relation as 2x plus z minus 2x plus y plus g. Then you have y plus 2z. Now the first question is find the image, find the kernel. Then the second question is associated matrix with respect to standard basis. Then the third bit, for all value of k find T inverse 3 k, and k belongs to R. And I can add some extra question. Does the vector 1 1 2 belongs to the image? Justify. Yeah, so this is the first question. It's a very basic question if you see. So first question is find the image, find the kernel, associative matrix with respect to the standard basis, and this, yeah, let's solve this too. You know how to find the kernels, you know, if
Yes.
all you just need to equate this to 0, all this thing. Let me just copy paste it. This equation equal to 0, this equal to 0, this equal to 0. So you can solve this equation. 2 0 1 minus 2 1 1
0 1 2.
0 1 2.
Bring it to the Deutschland.
Yeah, so it's 2 1 2 0 1 0 0 1 2 0 1 2. I can remove this one, so it's 2 0 1 0 1 2. This is 1, then you can write it as y plus 2z is equal to 0, z is equal to z, because last line will become
It's free variable.
yeah, so y equals to negative 2z, x equals to negative
Minus
z over 2, right?
Yes.
This first line you will get 2x plus z equal to 0, so x
Okay.
equal,
Yeah.
so if I write it x y z,
We can take out the z.
yeah. Okay, the kernel
Okay,
is this
yes.
one. Correct? Did you understood or no?
Yes.
You multiplied this to 2.
Yes, yes.
Okay.
You can keep it. It's your wish.
Okay, yes.
I prefer the solution to look good. I can also do 1 4 minus 2.
Okay.
Okay.
Yes.
So the dimension of the kernel is
2.
1.
No.
Don't be confused. Okay. 1.
The dimension of the kernel is the free variables. How many free variables we have?
Same. Actually, the dimension is the number of elements is there in the basis. So number of element is 1. So, and the number of elements is defined by the number of free variables that you have. So it's the same thing as the dimension of the kernel. So you can say it is the dimension of the number of the free variable, but when you reach to the final solution, just check it out how much number of elements that you have. Yeah, and you are dealing in R3, right?
Are we recording?
I guess yes.
Yes.
Okay, so you were the map was in R3, right? This is in R3 to R3. So you can say R3 is equals to the dimension of R3. We have discussed in the second video a lot about this one. It must be equals to the dimension of kernel plus the dimension of image. So this is 3 equals to 1 plus we don't know x, so x equals to 2. The dimension of image is equal to 2, so we can find the image, then we can check it out. So for the image, let's also so this was the relation, and we can send 1 0 0, and we will get 2 0 sorry 2 minus 2 0. If I send 0 1 0, I will get 0 1 2 0 0 1. I will get 1 1 2. Right, I choose the standard basis and I find the
I don't understand how this element.
this was the map it was given to us. So
Okay.
when you send like 1 0 0, the image of this one will be, you put it over here, the value of x is 2, here is minus 2 is 0. If you substitute this one over here,
Okay.
you
Yeah.
will get this value, correct? Now you already understood.
You put the value like x is 1, like here
Yeah.
2 minus 2 and 0.
Yeah.
Okay.
Can we say corresponding one to the main matrix? When we first the pivot ones that.
I will get back to that one.
Okay.
You wanted to say that, okay, from the associated matrix we can define the kernel, which we can say goes to 0. So it's the same thing that we did.
Yes, you
And-
know, like this row echelon form. We
Mhm.
can say that in the main matrix, the first column and the second column are the images, like this and this.
Yeah, I will say you that one.
Okay.
Don't worry. We will go back to it, and I want to like show the difference to you. That's why I am doing with the traditional method, and I will show you the associated one.
But
Don't-
actually, the thing that I said seems that wrong because I found two.
We are
But
not
here is
finished
three.
yet. We are not finished yet. So now the question: are these the images?
Not yet.
Yes, they are, but they are not the basis of images. You cannot write them like this because there might be someone who can be written as the other two things, other two
Linearly
vectors. So
independent.
you have to check.
If
Tax
I
is not yet over. The tax is not yet over. Check for linear independent. So you can put it here.
Why did you write the basis?
Since the question asked about image, you have to keep the basis of the image. That's the question it is asked. It asked also dimension of the image. That means you have to find the basis. Always, if it asks images for you, you have to write the basis. Correct? Then
I always have this question. When it comes to these bases, why we write it in the rows? But
Yeah.
in the other situation,
you-
we write them in the
Column.
columns.
Right? Our J. Jacob, he wrote in column. What's the difference?
We are doing something else here. We are just verifying our images are linear independent or not. We already got our images, but we have to check whether they are linear independent or not. So I'm using this row epsilon method to check whether all the terms are linear independent or not. Here I'm not solving any equation or not finding the associated matrix. I'm doing nothing. Those are different things. Now we are checking whether the images are linear independent or not. So the traditional method for linear independent is like you take alpha, you take beta, you equal to this one, then you find the value of alpha and beta is too long and it's complicated. I never do in that method. For me, just let me, if you do it in this form, if you get some line that is equal to 0 0 0, that means that term
Linear
is
independent.
linearly dependent on the both of them, so you can just eliminate it here now.
I want to say in the first matrix that we here. In the here we are again looking for the linear independent, right?
No, wait. Here is we are solving this equation to find the kernel. I have not reached this associated matrix yet. I have not reached yet. Don't think it's a matrix. Here, what I said, what is kernel? Kernel is like when it goes to 0.
Yeah.
So I took every equations equal to 0, and now I need to find the solution of this equation. So to find the solution, I use the row epsilon form. So it's not a matrix or nothing. So don't get, as I said, it's confusion is very easy. So don't get confused.
Now you want to find the basis of the images, right?
Yeah.
Okay, so you want to find whether they are
Yeah, so
linear independent. So.
I'm doing it. So I just swap this one here and I kept this one middle because it's more easy for me. It's 1 1 2 0 1 2, and this one I can write -2 and add it over here. So this one is 0, -2 I add it over here is -4, -2, just a minute.
-2 times of this one plus this.
Yeah, it's -4, right? And if I take -4 of this one, is -8. So I can eliminate this
No,
one.
it's not.
-4.
You're multiplying -2 to the first sources.
-2 times of this plus this.
You're right. So this is negative
-4.
-4.
Yes.
Just those my signs are correct because something need to be eliminated. Just a minute.
I think the way that you were supposed to copy these. Like if 1, so 1 1.
I made a mistake over here.
The copying thing.
No, not in the copying thing. If you take 0, this is 0, this is 1, and this is also 1. So there was a mistake over here. So since it is 1, this is 1 1, this is 1 1, and now I can eliminate this one.
How does this turn to point?
When you put 0 1 1 over here, this one is 0 and this one is 1 and this one is 1. You put this value over here.
Okay, let me.
This is 2z.
Yeah, but
So-
I'm doing
okay,
0
right,
1
yeah.
0.
That's correct. Yeah.
Correct? Correct?
Yeah, like 0 from here, 1 from here,
This
and 1
is
from here.
like X, Y, Z. You put the values
Yeah,
here.
yeah.
Ah, okay.
That's
Done.
correct.
So I got this one as linear dependent. So I I can just remove this one, and then my image is 1 1 2 0 1 1. So the dimension of image is
2.
now this is the most traditional method that we do, and it's not that difficult as well. One more thing. Second question. Associated matrix. Associated the generator of the images when you it was with respect to standard basis, right? Standard basis. When you with the generator of the images, when you apply standard basis, are the columns of the associated matrix. So in short, I got these three, right? So when I applied the when I sent it to the image, so I got these three as an image. So these are the generator of the image, not the basis of the image. So these are the things which I got when I calculated the image. So this must be the columns of the associated matrix. So this is the associated matrix A.
You mean the rows here are the columns?
Yeah.
Okay, why does that happen?
It's like
What do you mean by associated matrix? I mean,
associated matrix. You can actually the meaning of associated matrix. You can define this relation. You can define this relation with that matrix. So we got our associated matrix as this one 2 0 1 minus 2 1 1 0 1
it's
2.
okay if we write only this without further
Yeah.
explanation.
Yeah.
Yeah, could we solve the associated matrix without solving the first part?
Yeah.
Right?
I was getting back to that. If you have this relation, so your associated matrix with respect to standard basis only. The rest one I will tell you how to do it. But if the question asks associated matrix with respect to standard basis, you just look this one. You take the coordinates from here 0 1 minus 2 1 1 0 1 2. Check it out, both of them are same.
So by the standard basis, you mean the
Yeah, just say this one. If you think in standard basis, what you do, you just send 1 0 0 0 1 0 0 0 1. So you are just taking only the coefficients. So here the coefficients are just the I just written like this, and
Yeah,
it's
they're
not a
the same.
matrix.
Like,
Yeah.
yeah.
But why I said the this one for you? Why not I said that definition before? Because when the basis changes, most of the people when the question asks write the standard basis with respect to the vector v, you cannot do that one. You have to. This is always valid. Uh, this is always valid. The generator of the images are the columns
That's
of the
change of basis. That's
yeah
different.
that you will see the change of basis. But sometimes in a hurry you just do it that okay associated matrix has been asked, I know how to do it, You take the coefficients, you put it in the matrix, you say no, this is the associated
Okay.
matrix.
Wait, so
No, but first you have
these
to
are the
solve
standard
and
basis, right?
Yeah.
say if
No,
they
I,
are
I
linear.
said what are the common errors. I'm saying that. I'm saying the common errors. So as he said, he asked me one question: can we write the associated matrix without even solving this two?
Is it
I said,
correct?
yeah, you can. You take the common. This is the associated matrix for this one.
Okay.
But this is only valid if and only if it is asked about standard in the standard basis.
The standard basis are these three, but written as this.
Standard basis.
100.
Standard basis for R3 is 100,
Okay, yeah.
10.
So with respect to standard basis, that means that we'll have to put this and this
Yeah.
and then write them.
The traditional method for associated matrix is that one that I have said you.
Okay, so then we're going to write them in row form again, not column.
Which one row form? I said you the images. Note my word. You will never forget it. The images generated by the standard basis are the columns of the associated matrix.
This is like the best explanation.
Explain. The images generated by the standard basis are the columns of the associated matrix. But if you want to do something different, you want to just copy it, you can just take the coefficients and put it normally.
For
Okay.
checking is good. I mean, you can check.
You can check and normally. But don't get confused. Only remember one definition. The images generated by the standard basis are the columns of the associated matrix. And there might be one more question in his mind as well. I know. Let me address it without he asks as well. So, for example, if you are given with a linear map that goes from R3 to R3, and R3 to R3, and this is given a standard basis, and the associated matrix is given to you as 2 0 1 0 1 2 1 1 1. This is the associated matrix given with the associated matrix with respect to standard basis is given to you. So you can instead of doing anything, you can say images are the columns of the associated matrix. So I can say 2 0 1 like this, then 0 1 1, then 1 1 1. Wait, it's not finished yet. You have to check whether they are linear independent or not. So to check whether they are linear independent or not, put them in the epsilon form 0 1 1, and the row, if any row become 0, simply eliminate it. Rest you will remain with the basis of the image. Is it clear now? Completely. Now will you get confused? Still, okay.
These are the standard basis.
Yeah.
And these were the matrices.
Images, but the generator of the images. To define finally that whether it is an image or not, you have to say that whether they are linear independent or not.
Okay, so what's the difference between images and an associated matrix? Because if we're writing the
complete.
If we're you just said the columns of the
you complete your question first.
If we're writing the images by using these 1 0 0 0 1 0 0 0 1, we put these in this, right? So 1 0 0, that would make 2 and 0 1, or 2 0 0.
2 minus 2 0.
Okay. Yes. So 2 minus 2 0.
Yeah.
Right now we're putting them in columns.
Yeah. Images,
This is for the images.
the generator of the images with respect to the standard basis
Okay.
are the columns of the associated matrix.
Okay, so when we are trying to take out images, we put this in like 1, minus 2, 0, and we write them in columns.
Yeah.
I repeat it with all those three.
Yeah.
But when associated matrix, then we write them in rows. Like 1, I would make 2, then
Wait.
minus 2.
Wait. First part that you said is correct. I
Yes.
didn't understand your second question.
Okay, then how would you write associated matrix?
This is the associated matrix. These are the okay.
Where's the image?
These are the images. The generator of the images.
Oh.
And but we cannot directly
Okay.
say
In
this.
images, you write them as rows.
These are images. Don't think about rows or column. These are simple images.
Yes.
These are images, but you cannot directly say that there are final images because you have to check whether they are basis or not. For basis, they must be linear independent. So for linear independent, I just use row epsilon to check whether they are linear independent or not. This is not a matrix, nothing. It is nothing related to the associated matrix.
Okay.
It is something which I am using it for linear independent or linear dependent. Don't get confused. This has
Sir,
no-
three vectors like that.
yeah. So this has no relation with associated matrix. No relation with. I am just using this one. I am just using this to
If
very
they are linear independent or not.
verify linear independency.
Okay.
So it has no relation with the matrix. But for the associated matrix, if you have any questions, by this it should be clear. You just remember one definition: the generator of the images when you apply the standard basis are the columns of the associated matrix.
Even if they are not bases.
Even if they are not, I said generator, so it's like if you take the basis, you should think that there would be like one thing is missing because
Yes.
so it's not an associated matrix. And reversely, if you have a map that goes from standard basis to standard basis, R3 to R3, and you have the associated matrix, the columns and images, the question asked about the images. So the images are the columns of the associated matrix. So the images are the column of the associated matrix. But wait, the work is not finished yet. You have to check whether they are linear independent or not. You have to use the row epsilon method for checking whether they are in linear independent or not. If one of the row becomes 0, simply eliminate it. Rest you will remain with the basis of the image.
Okay.
Now am I clear? All the questions related to this. Any confusion?
No.
Sure?
Yes.
100%? Okay. For example, in this question, you have given with associated matrix in the linear map. I'm talking about this question, not that question. Like I'm just taking an example of this one. So for example, kernel is asked to you. You can also solve the kernel directly from associated matrix. You can write ax equal to 0. So associated matrix, you have the x, x1, x2, x3 equal to 0. By doing this is the same thing you are doing what over here, like over here you are equating everything to 0, right? It's the same thing. If you take the associated matrix x1, x2, x3 and that equate to 0,
Yes, same.
it's the same thing. And I have also second question I have done with like that method, and I have written that you are doing the same thing. So is the kernel equate all equation to 0. Similarly, we can write associated matrix x1, x2, x3, x4 equal to 0. Both are the same thing. Either you do by this or you do by that, but don't get confused. Here matrix is just one. Rest we are using for linear independent or linear dependent. It's up to us. The last question is this one. Find the value of k such that this 3k is equals to you have to find the pre-image of this one.
T inverse.
Yeah, you have T inverse is like you have to find the pre-image of this one. Like the simple method to do is associative matrix multiply x is equals to that vector 3 3k, I guess.
Associated matrix times to the vector x.
Yeah.
Should be that.
Yeah. Either, yeah, it's the same thing. So our associative matrix was this one.
There's two unknowns.
Yeah. One unknown, right? Okay. So if you solve this equation, it will be something like this: 2 0 1 minus 2 1 1 0 1 2 3 3 k. Then you solve it for different value of k. But is it the only method to do this? No. The one more method, if you go by definition, if just a okay, so the question asked,
Find the pre-image of the.
original question was T inverse 3 3 k. This was the question, right?
All of them will be equal to this. This one
Yeah.
equal to this.
So it's another method, like you can equate this equation: 2x plus z is equals to 3, then minus 2x plus y plus z is equals to 3, and y plus 2z is equals to k.
Okay.
So if you solve this one, 2 0 1 minus 2 1 1 0 1 2 3 3 k
Okay.
is the same thing, right?
Yes.
Yes, it's the same.
Yeah. So don't get confused.
Well, the last method was by the definition was correct. When we find the associated map, we can just find the pre-image.
Yeah. But I'm covering on both the easy method because you might get confused.